Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try these problems in your notes, and then unpause it, and let's talk. So, what is different about these two pairs of trees? We have pair number A, we have pair A, we have pair B. Well, notice that in pair A, the trees are exactly the same. You probably noticed that. You probably said, what's different? Well, pair A is exactly the same, and pair B, one is smaller. The trees are the same, but one is smaller. And then it says, what is the same? So what's different about the two pairs? Well, in pair B, one of the trees is smaller. But what is the same? Well, it's the same tree. It's the same tree. So all of these trees are the same. This fourth one just happens to be a little bit smaller. So how could you use math words to describe what is the same and what is different? Well, we know that if two things are exactly the same, they have the same shape, so they're the same tree, and they have the same size. So the trees are the same size. That means that they are congruent. So pair A, the trees in pair A, are congruent trees. The trees in pair B can't be congruent because this tree is smaller. They're not exactly the same. The shape is the same. They're both trees, but the size isn't the same. So we can't use the word congruent because that's taken for same shape, same size. So there's a new math word that we're going to learn about in Chapter 8. This is the beginning of Chapter 8. It is called similar. The shapes are similar, but they're not exactly the same. So, congruent, same shape, same size. Similar, same shape, different size. Kind of like a dilation, like we learned about in Chapter 4. And not kind of exactly like a dilation that we learned about in Chapter 4. So, how could you use math words to describe them? Pair A, the trees in pair A are congruent. The trees in pair B are similar. Okay, wonderful. That's a nice intro to what we're learning about in Chapter 8. Now, let's dig into what will we learn about in 8.1, the first section of Chapter 8. 8.1 is all about similar polygons. You remember what a polygon is? It's a closed figure with lots of sides. So we're going to talk about polygons that are similar. Same shape, different size. So the essential question, how are similar polygons related? What's the same about them? What's different about them? So our learning target is that you know what it means to be mathematically similar, right? You probably know what similar means, right? My sister and I are similar because we both have blonde hair and we both really like pizza. But mathematically, what does it mean to be similar? So that's our learning target. Our success criteria is that you can find scale factors. Remember that word from section 4.5 when we talked about dilations. There was always a scale factor for our dilations. So you can find scale factors and corresponding lengths in similar figures. Okay, so next we're going to move on to some vocab, which I put review question mark. I'm not 100% sure if these words will be review for you, but after we go over these words, I'm going to show you an example. I think they're review, but I put a question mark because you never know, and it's okay if it's not review. If you don't remember this stuff, that's okay. We're going to talk about it now. So, the first word is a ratio. It is a comparison of two quantities. So the ratio of A to B can be written as A colon B. It can also be written as A over B. It can be written as a fraction. So you can take the ratio of anything. You can take the ratio of boys to girls in the class. If there is one girl for every two boys, it means that there's twice as many boys as there are girls in the class. Okay, so that's what a ratio is. We're just comparing two quantities, number of girls, number of boys, number of M&Ms, number of Skittles, whatever you want. But it needs to be two quantities. So you're comparing two numbers. Number of boys, number of girls, number of Skittles, number of M&Ms, whatever. Now, a proportion is similar to a ratio, but we are making two ratios equal. So I could say the number of, or the ratio of girls to boys is the same as the ratio of people who like M&Ms, and the ratio of people who like M&Ms to the number of people that like Skittles. So the proportions need to be equivalent fractions. If you don't remember equivalent fractions, that's like 1/2 is equal to 2/4, etc., etc. Which is equal to 3/6, yada yada, you get it. So 3/4 is equal to 12/16. So that's what a proportion is. A proportion is when you set two ratios equal to each other. Okay, so if you don't remember these words, hopefully you do. If you don't, that's okay. I want to do a little bit of an example. We're going to call it example 0 as a nice warm-up. So I want you to try this problem by yourself. I want you to pause the video and do this problem in your notes. If a 24-ounce box of Frosted Flakes costs $4, how much should an 18-ounce box cost? How much should it cost? Not how much does it cost, but how much should it cost, right? Because sometimes they charge more than they should in stores and such. So, pause the video, answer this question. Unpause it, and then we'll talk. So, I wanted you to try this problem by yourself because there are many ways that you can do this problem. One of the ways that I see more often in students is they say, okay, 24 ounces costs $4. That means if I spend $1, I will be getting 6 ounces, right? These are equivalent fractions. We just divided by 4 on the top and bottom. And then they say, oh, okay, 6 ounces is $1. I have 18 ounces. 18 ounces divided by 6 ounces, that's 3. So I should pay $3. Because each ounce, or each dollar is 6 ounces, and 6 goes into 18 3 times. So $3 for 18 ounces. That's one way that you could have done this. That's one way you could have done this. Another way, and I'm going to change colors because this is another way. Another way you could have done this was you could have said, so 24 ounces is $4. That means that 18 ounces is, I don't know how many dollars. It's X number of dollars. And then you can cross multiply, which means you're multiplying the numbers across from each other. So 24x equals 18 times 4, 72. Divide by 24 on both sides, and x equals 3, or $3. I like to call this butterflies. When we cross multiply, it kind of makes a shape that looks like butterflies. So, I like to call cross multiplication butterflies, because cross multiplication sounds big and fancy, but butterflies, those don't sound big and fancy, those don't sound scary. unless you don't like butterflies. I don't like butterflies. That's another story for another time. So, and there's actually another way you could have done this as well. So you also could have said, oh, well, how much should it cost? Well, the ratio of ounces in the cereal, how much cereal I am purchasing, that should be proportional to the price that I'm paying. So the ratio of ounces needs to be equal to the ratio of cost. And when I set two ratios equal to each other, I get a proportion. So we say that the number of ounces, or the ratio of ounces, should be proportional to the cost. Now that's what it should be, right? Oh, and I'm sorry, if we cross multiply here as well, we get 24x equals 72 again. So there are three ways that you can do this. Two of them involve butterflies. One of them involve a scale factor. Scale factor. Remember that from section 4.5. If you don't, I will put a link in the description to the video from section 4.5, so you can go back and review that, review scale factors and stuff like that if you would like. Okay, so now we say how much should it cost, because sometimes, right, sometimes the 18-ounce box of cereal is like $13.20. And so you have to decide, oh, is it cheaper to get the 24-ounce box, or is it cheaper to get the 18-ounce box? So when people say, when am I going to use this in my life? This is actually one example of something that I do use every time I go to the grocery store. Should I buy the smaller bottle of olive oil, or should I buy the bigger bottle of olive oil? Where am I saving money? And you might think, oh my goodness, it's a difference of 20 cents, Mrs. Dodge, or like $1.20, or excuse me, 80 cents. The difference between $3.20 and $4 is 80 cents. 80 cents stacks up. Wait until you're buying 5 boxes of cereal, and then 80 cents times 5 is like $4. I think, if I did my math right. Okay. All right, so now a little recap. Now it is review, because we just talked about it. A ratio is the comparison of two quantities, 24 ounces to 18 ounces, and a proportion is stating that two ratios are equal. So 24 ounces to 18 ounces is equal to $4 compared to $3. So these ratios are equal to each other. That's a proportion. A ratio is like just one fraction. A proportion is two fractions being equal to each other. Wonderful. All right, now we're going to move on to some more vocab that is review. Corresponding parts. This was from section 5.2. I'll put a link to that in the description as well if you want to go back and watch the video from section 5.2. But corresponding parts are a pair of sides or angles that have the same relative position in two congruent figures. So angle A is corresponding to angle D because they're both the smallest angle in the shape. Angle B and angle E are corresponding because they look like the biggest angle in the shape. And then DE and AB are corresponding because they're both the side in between the smallest and the biggest angle, etc., etc. So if you want to know more about corresponding parts, you can watch that video. Link in the description for section 5.2. So, angles correspond with angles, sides correspond with sides. Please don't tell me that angle B corresponds with side AB, because it doesn't. Sides go with sides, angles go with angles. All right. Another vocab word, I believe this is the last one, is similar figures. So, we talked in the entry task about similar figures, but here is the robust definition. geometric figures that have the same shape but not necessarily the same size. Now, figures that are congruent are also similar, but figures that are similar are not necessarily congruent. So that's why we say not necessarily the same size, because they can have the same size, but typically we call that congruent. So when you look at this example they gave here, you'll see this is a dilation. This is a dilation. We took whichever one of these was the pre-image. It doesn't say, it doesn't give us any primes or anything like that, so we don't know which one was the pre-image. But if I'm starting with the blue shape, I shrank it, and it looks like I reflected it as well. Yeah, I shrank it by a factor of 3. So I made it 3 times smaller, and I reflected it over the y-axis. So, and if I went from the green shape to the blue shape, I made it 3 times bigger. So the scale factor here would be 3. If you'd like to review any information on dilations, link in the description to section 4.5. You can watch that video. So, similar figures are just figures that have been dilated by some scale factor. Any two figures that are similar can be mapped to one another with a dilation. So I can tell you how you get from the blue shape to the green shape with a dilation. Because they are similar figures, I can turn the blue shape into the green shape with a dilation. If you can't turn one shape into the other with a dilation, well, they're not really similar, are they? Okay, wonderful. That was the last vocab word. So now, important information. Corresponding parts of similar polygons. So this kind of combines the 2 vocab words that we just talked about, corresponding parts of similar polygons. So, the important thing to take away from here, well, there are many things, but in the diagram below, triangle ABC is similar to triangle DEF. We can write that using this little squiggle. So triangle ABC is similar to triangle DEF. This means similar, or is similar to. Now remember that you have to go in the same order of corresponding parts. So if A comes first and D comes first, it means that A is corresponding to D. And if we look at the pictures, yes, A is corresponding to D. So make sure that if you're writing a similarity statement, you need to write it in order. If we go A, B, C, our next similarity statement needs to be D, E, F. We need to go in order, in the same order. All right, another important thing to take away is that a similarity transformation preserves angle measure. When I dilate a figure, I don't change the angles. The angles stay the same. So, corresponding angles are congruent. In similar polygons, angles are congruent. That's important. I would write that down. And a similarity transformation enlarges or reduces side lengths by a scale factor k. So, corresponding side lengths are proportional. Angles are congruent, sides are proportional. Which means to go from side AC to side FD, I just take B and I multiply it by the scale factor, right? That's what we did for dilations. We just took all the points, all the x's, all the y's, and we multiplied by a scale factor. So we're going to do that again with similar figures, because similar figures are dilations. They are one and the same. All right, so a little recap. Corresponding angles should be the same. They will be congruent. But the side lengths will all be proportional to the scale factor. So the ratios of side lengths will give you the scale factor, and all of those ratios should be equal to one another. All right. We're going to jump into our first example. There are 3 parts to this example. First, find the scale factor. Second, list all pairs of congruent angles. And lastly, write the ratios of the corresponding side lengths in a statement of proportionality. So, let's start with part A. Find the scale factor from triangle RST to triangle XYZ. Now, they told us that these shapes were similar. I don't need to check and make sure that they're similar. I know they're similar. I know side lengths are proportional. So, if I want to find the scale factor from RST to triangle ZXY, that means that I'm going to take a corresponding side. So I can see that RT is corresponding to, go in order, RT, XZ. I almost wrote ZX. We want to go in the same order. So, if I'm going from the big shape to the small shape, my scale factor needs to be small. It needs to be smaller than 1 because I'm making this shape smaller. So I'm going to put the big number on the bottom. Whoops, I'm actually going to put RT on the bottom and XZ on the top, because the smaller number should go on the top because we're going from bigger to smaller. So, this is part A. XZ is 15. This side is 15 units long. And RT is 25 units long. And if I simplify this, I can divide by 5 on the top and bottom. We get 3/5. So if I want to go from RST to triangle XZY, I would need to multiply all of the sides by 3/5. If I take 25 and I multiply by 3/5, I get 15. If I take 30 and I multiply by 3/5, I get 18, right? Because those sides match. So, if I go from the big triangle to the smaller triangle, the scale factor is 3/5. Okay, part B, list all pairs of congruent angles. So, we know that corresponding angles are congruent. In similar triangles, corresponding angles are congruent. So, let's do this in a different color. We'll take red for part B. List all pairs of congruent angles. Well, angle T corresponds with angle Z, so they are congruent. Angle R corresponds with angle X, so they are congruent. And angle S corresponds with angle Y, so they are congruent. All right, and lastly, we want to write, and I'll get a different color for this, we want to write the ratios of the corresponding side lengths in a statement of proportionality. So, we found our scale factor, we found our corresponding angles, now we want to know how do the sides relate to each other, right? We talked about how the angles related to each other, but now how do the sides relate to each other? So remember that sides are proportional, which means we're going to take all of one triangle's sides and we're going to put them on top of the other triangle's sides. And we're going to make sure that the corresponding ones are in their own ratios. So, let's take triangle RST and triangle XYZ. It doesn't matter which one is on the top or the bottom. It doesn't matter. So we can put XYZ on top if you want. It doesn't matter. Let's keep triangle XYZ on top because we put XZ on top over here. So what we're going to do is we're going to pick whichever side you want. Let's start with these. Let's start with XZ and RT because we already did that. We already know that they're proportional. Then we're going to pick another side. How about ST and YZ? ST and YZ. Make sure that you stay consistent. If triangle RST is on the bottom, all of the sides for triangle RST need to be on the bottom. Stay consistent. And lastly, the last side is RS and XY. So this would be our statement of proportionality. The ratios of all of these sides are equal. And in fact, they are equal to the scale factor. Okay, and there you go. That's part C, all done. So we found the scale factor, we listed the congruent angles, and we made a statement of proportionality for the side lengths. Let's check and make sure that we were correct. Yes, from RST to XYZ is 3/5. They did it with all the pairs of sides. You only need to do one. Because we know that the triangles are similar, we only need to do one. Scale factor is 3/5. Listed the congruent angles, and listed the statement of proportionality for the side lengths. Cool. We were right. Okay, one more example to do. First, corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths of the polygon is equal to the scale factor of the similar polygons. So what this means, any two corresponding lengths. So if I know that the polygons are similar, I can work with two ratios of corresponding lengths instead of all three of them. That's what that means. Okay, and corresponding lengths in similar triangles, that's side lengths, altitudes, medians, midsegments, all of those pieces of a triangle can correspond. Okay, so we're going to find a corresponding side length. So, in the diagram, we know that these two triangles are similar, which means I only need to work with two of the corresponding sides. I don't have to work with all three. So, we want to find the value of x. Well, what I can do is I can look at triangle DEF, and I can compare it to triangle MNP. I can write a statement of proportionality. So, x is side EF, and side EF corresponds with side NP. And in fact, we can write it that way. We can write side EF corresponds with NP, which gives us x over 20. And remember our statements of proportionality. Pick another side that you like. Let's do ED. ED is the same as NM. And ED is 15. And NM is 18. Now, I have a proportion involving the side lengths of my similar triangles. So now, all I have to do, butterflies, cross multiply. So we're gonna do x times 18, and that's what, when we draw these little ovals here, it means I'm doing x times 18, which is 18x. And then I'm doing 20 times 15, which is 300. I like to draw little antennas. Okay, how do I solve this equation? Divide both sides by 18. 300 divided by 18 is 16. I did something wrong. This is 30. This is 30, not 20. Sorry. So we need to do 30 times 15. If you caught that, good for you. So this should be 450. I'm sorry. Everybody makes mistakes, even the teacher. So if you get something wrong on your homework, hey, so did I. 450 divided by 18 is 25. So x is 25. Wonderful. You could check by plugging it back in and making sure that these ratios are all equal to the scale factor, but I'll leave that as an exercise to the viewer. Let's check and make sure that we were correct. MN to DE is equal to NP to EF. Oh, yup, they did the same thing as we did. They just flipped the fractions. Remember, it doesn't matter. Yeah, there are several ways to write the proportions, so you could have put triangle DEF on top and triangle MNP on the bottom. There are several different ways to write these proportions. The important thing is that we cross-multiplied. We got x equals 25. Check. Boom. Awesome. That is all I have for you today. A little longer of a video than perhaps what is usual because we were just introducing you to similar figures. So if you have any questions, you know what to do. Ask a friend, ask a teacher, ask your parents, see if they know. I don't know. And rate yourself on a scale of 1 to 3. What is your understanding of the learning target and the success criteria? Are you horribly confused? Do you think you got it? You want to try the homework? Or do you need to help your friends and family with their homework and their understanding? So be sure to rate yourself on your understanding of the learning target and the success criteria. Here are some practice problems that you can do to practice the skills you have learned in this video. These problems are like example 1. These problems are like example 2. And lastly, we'll end our video with a launch. Today's launch comes from Albert Einstein, and he says, "Education is what remains after one has forgotten what one has learned in school." We all forget things that we learn about in school, right? I learned about the French Revolution in high school. I couldn't tell you much about the French Revolution other than the word bourgeoisie, because I really liked that word. So, education is what remains after you've forgotten. What do you still remember when you've forgotten what you learned in school? So, education is the stuff that, yeah, it's what you remember after you forget everything you learned in school. So, what do you want to get out of your education? What do you want to remember after you leave school? It's up to you, right? So, like, French Revolution would be cool to know about. I would rather know more math than know about the French Revolution, personally. So, you need to choose. What is most important to you? What do you really want to remember when you leave high school? Focus on that for your education. Obviously, do well in all of your classes, but education is what you make it. It's what you work hard to remember after you leave school. So, what do you want to work hard to remember when you leave school? And what steps are you going to take to make sure that you remember the things that you want to remember? So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.